This section will cover 5.4 and 5.5, where we're working with dividing polynomials and finding their x-intercepts, or you can call them zeros or their roots. For the warm-up, that's going to come back to what we covered in the last section. We want to find a polynomial that has all of these things as a part of it. N represents your highest power. So let me go ahead and write highest power. So we know that it's going to be x to the fifth. We want a y-intercept of -9. We want an intercept of 3, 1, and -1, and they each have respective multiplicities. Multiplicity of 1 means it doesn't have a power. And then we have some end behavior. It looks like it's going down on both sides. Okay, so no, it's not. That is not a negative. That's going up. Makes more sense for an odd power. Okay. I'm just going to go ahead and start by writing out all of these in my factored form. So I have x minus 3 with a squared outside, x minus 1 with a squared outside, and x plus 1 with a squared outside. Just quickly checking that does not have a square. I'm currently doing this on the tail end of a sinus infection. I'm very sorry for the mistakes you're about to see. Hopefully I catch them all. Just looking at this, I do see 5 x's, so that part is done. I'm also going to quickly check and see if my y-intercept is correct. So I have -3 squared times -1 squared times 1. That's actually going to be a +9. So that tells me I should put a negative out front. So now that works. So we got all that. Now let me check my end behavior. So if my end behavior looks like this is a negative power of 5, which I've already taken care of with that minus out front. So there's going to be the equation for this polynomial that has been described. Without using a calculator, find the quotient and remainder. So the reason we're doing this is to kind of just show you how tedious long division really was back in the day. Because we could use it to divide polynomials, but we are not going to. So let's go ahead and divide. So 21 can go into 28 once, multiply, bring it down, subtract, multiply again. I think this will go 3 times. That'll be 63, and we have a remainder of 16. That's all you would do there. So essentially, this is what we would be doing with the polynomials, but we're not going to. We're going to do something called synthetic division instead. Here's your division algorithm. It just essentially says what you get out of the division can be multiplied by what you divided by, and you can add the remainder. This won't be something that you're going to get tested on. It's just there to kind of show you the different setups of a polynomial when you're dividing. All right, here we go with synthetic division. The process for synthetic division is actually pretty straightforward once you see it for the first time. You're going to have a little box and then a longer rectangular box. In the little box, you're going to go ahead and put the solution for the denominator, right? So this is essentially saying 5x squared plus 3x minus 2 divided by x plus 1. If you solve the denominator, you're going to get -1. So that's what we're going to put in this little box. In the long box, we're going to put the coefficients of the quadratic, right? There's the 5, the 3, and the -2. Now, step 1 is bring down the first term every single time, okay? And then from there, we will take the 5 and multiply by -1 and put that number in the next column. It's going to be -5. We do that math, right? We're going to do 3 minus 5 and get -2. And then we're going to do it again and multiply by that -1 and put that number in the next column. If for some reason this is not 0, okay, then what you divided by is not a factor. For us, the goal is for it to be 0, so I'm always going to try and give you ones that equal 0, because if it doesn't, then you kind of are at a dead end. The result is 5x minus 2. There's the 5, there's the -2. The reason it drops a power is because we've divided out an x. If I have x squared over x, that leaves me with just an x. And there it is right there. Let's repeat that process with this one. Excuse me. 6, 11, -31, and 15. Step 1 is bring down the first term, multiply. Oops, I definitely just added. That's going to be 12. Now we have 23. Multiply by 2. That's going to be 46. Go ahead and do that addition. That's going to be 15. I believe. Yep. Multiply by 2. That's going to be 30. We're going to have 45. So this has a remainder. I'm doing one example with the remainder so you see what happens. This means that 2 is not a factor of the polynomial. Oops. Nothing else you can do there. It's just not a factor. Now, let me tell you really quickly when we use synthetic division versus long division. We used to do long division in college algebra, and we have actually kind of dropped it. But synthetic division can only be used when the leading coefficient of the denominator equals 1. So essentially this right here, that has to equal 1. If you were dividing by, let's say, 3x minus 2, that's when you have to use long division. As long as that is not a 1, you cannot do synthetic division. So same thing, if we had 2x plus or minus or plus whatever, again, there's a 2 there, we cannot use it. In our class, we're just going to use synthetic division, which means everything you're dividing by has a coefficient of 1. Right, in the next part, we're going to do synthetic division, and then we'll ideally find the remaining x-intercepts. I'll show you what's going to happen after we synthetically divide in this problem. So there's our little box, and we have 2, -1, -15, and 18. Bring down the first term, multiply, do the math, multiply, do the math, multiply, do the math, okay? Great, we got 0. So that means we have 2x squared plus 3x minus 9 remaining, and we divided by x minus 2, which was a factor. So now this quadratic, I can go ahead and factor as well. So I'm thinking we're multiplying to -18, we're adding up to 3. That's probably going to be 6 and -3. We have 2x squared plus 6x minus 3x minus 9. Let's factor by grouping. And now we're going to have 2x minus 3, x plus 3, and the x minus 2 from before. This would be your factored form. If I want x-intercepts, I have 2, 3 halves, and -3, or you could write them as coordinates. Your choice there, okay? But those are going to be all of your x-intercepts. You're going to have 3. This would be your factored form. Moving on to the next one, we'll have something similar. We are going to go ahead and divide by that -1. We have 1, 3, -6, -24, and -16. Bring the first term down and then start multiplying. Multiply by -1. Now multiply again. Now we have -8, and then a +8, and then a +16, which gets us 0. So now we have x cubed plus 2x squared minus 8x minus 16. All of that is multiplied by the original thing that we divided by, x plus 1. Now I'm seeing that this is a cube function, but it is factorable by grouping. So let's take out the x squared and we're left with x plus 2. Take out a -8 and we're left with x plus 2. Now we have x squared minus 8 times x plus 2 and the x plus 1 from earlier. Again, this would be your factored form, whereas your x's are going to be -1 plus or minus √8 and -2. Note that if you did simplify this, it would be 2√2. I'm okay with √8 if you didn't simplify further. That takes us to 5.5. This is really just a continuation of the previous section, so that's why I kind of combined them. Let's take a look at these warm-up questions. How is the range related to the degree of the polynomial? So if you think about a odd function, you have n behaviors like this. Okay, you have a positive one on the left, you have the negative one on the right. So if you have a odd function, your range is going to be all real numbers. For anything that's even, it's going to have some sort of minimum or it's going to have some sort of maximum. So there is some sort of limitation that we might not know. So that's how they're related. Is it possible for a graph to have no y-intercepts, no x-intercepts, and explain? So it must have a y-intercept every time. It also can't have more than one because it's a function, so it has to pass the vertical line test. But there are functions that don't have x-intercepts. Anything even could avoid having an x-intercept. There's a couple scenarios. So if I had a even function and it was negative and fully downward facing, it would never touch this axis. And the same thing if it was positive and upward facing, it would never touch the x-axis, right? They would all have imaginary roots, like a negative root. In synthetic division, y is the degree of the quotient, 1 less than the dividend. We talked about this earlier. So if my um, polynomial was a power of 3 and I divided out an x, I'm actually just subtracting the 3 minus the 1 power to leave me a power of 2, right? The same thing if it was squared over an x, I would have an x remaining. So that's why we're dropping a power. This is essentially a continuation of what we just did on the last section. Let's go ahead and divide and see if we can find the remaining factors. We'll put 4 in the little box, -3, 6, and 24. Bring down the -3, multiply, do the math, and multiply again. So now we have x is equal to 4 from x minus 4 in parentheses. And we also have -3x minus 6x. And solving that, we get x equals -2. So our two factors of this quadratic are 4 and -2, which makes sense. It's a power of 2. It can have two roots. Let's do the next one. It's a power of 3. Chances are we will factor the quadratic that comes out at the end. 2, 1, -5, and 2. Bring down the first term and multiply. Do the math, multiply. Do the math, multiply. We end up with a 0. We have 2x squared minus 3x plus 1. That means we are going to using, let me think, -2x and -1x. So we'll take out a 2, take out a 1. Oops, 2x. Do x minus 1 times x minus 1. Keeping in mind we had the original x plus 2 from earlier. So there's your factored form. If you want to leave it in factored form, if it says what the factors are, that's an option. And then your x-intercepts would be -2, 1/2, and 1. Okay. We'll factor and then draw a little sketch. I noticed that this one is factorable by grouping, so I'll go ahead and start there. I will take out a 4 on the other side. I have x squared minus 4, x plus 2. This is x plus 2, x minus 2, and then x plus 2. So what I'll write is x minus 2 and x plus 2 squared. So remember, that's a multiplicity. So now I have all my points. So that's 1, 2, 1, 2. My y-intercept is -8. I'll put that down here. This is a positive power of 3. So I know my end behavior is going to have that sort of shape. And then at -2, I have a multiplicity, which means I'm going to bounce and go back down. And based on the arrows, I can tell that that's the direction we're going to go. And then there we go. It's not a very pretty curve, but you get the idea. Let's do the next one. All right, an important note is we go from 3 to 1 instead of having a power of 2 in the middle. So something to keep in mind, you are going to incorporate that by including a 0. This comes up in the homework. It's not on the quiz. I like to point it out so that I think I did something wrong. -1, 1. Oops. This is what I get for trying to talk and do math at the same time. I like to point it out because it comes up in the homework, and that way you're not like annoyed and frustrated that you keep getting it wrong, even though you're doing all the steps right. So that's why it's in here. This one needs factoring as well. X minus 3, x plus 2. So we have an intercept at 3, -2, and -1. -1, -2, 1, 2, 3. And then a y-intercept at -6. And this is also a power of 3. So I know my end behavior is going to look like this. And now we just follow it along. No multiplicities here. Okay. Last two of the day. We'll do some synthetic division again and then find any remaining x-intercepts. Bring down the first term, multiply, do the math, multiply, do the math, multiply, do the math. There we go. We have x cubed plus 3x squared plus 2x plus 6. Factor by grouping. Take out the 2 on the other side. We're left with x squared plus 2 and x plus 3. Remember, we have the x minus 1 from earlier. So my x-intercepts are going to be 1, negative, or I should say plus minus I root 2 and negative 3. So this is going to be imaginary, obviously not graphable, but still going to be an answer. One more time. 3, 5, 7, 15, and negative 6. Bring down the first term and multiply, do the math, multiply, do the math, multiply, do the math. We're going to have 3x cubed minus x squared plus 9x minus 3. Again, factorable by grouping. I'm always going to try to give you stuff that's factorable by grouping. Otherwise, you kind of end up in a little bit of a pickle. Now we have x squared plus 3 times 3x minus 1. Don't forget the original x plus 2 that you divided by. And your x-intercepts will be negative 2 plus or minus I root 3 and 1/3.